Okay, in the last lecture, we discussed the distance variables. Now I want to discuss the velocity variables. We defined average speed, or the speed variables and velocity variables, the things that describe how fast your distance changes. So now we will define average velocity. Average velocity is quite different than average speed. Average velocity is defined as the rate of change of displacement, often denoted as just V average, and it is simply the rate of change of displacement, so that must mean that it is displacement over time elapsed. Right, time elapsed. Now, I gotta be a little bit, not terribly careful about the time variable. Total time is what I called it before. Total time. So let's just say that the bunny starts at some t initial and finishes at some t final, right? Starts at some position x initial at some time t initial. It starts at noon and it gets to x final, the final position, at 5 past noon, right? So the time elapsed is 5 minutes, right? TF minus TI is 5 minutes. We more often than not just refer to that time as t. Right? You can call it delta t because it is delta t. Delta t is t final minus t initial. But for simplicity's sakes, because more often than not, actually, t initial we're just going to say is 0 and t final is 5 minutes. So the delta t is 5 minutes, or the time t equals 5 minutes after we started. Maybe that's a little bit confusing and we should be careful and just always call this delta t. But we are talking about, when we're talking about the rate of change of things, we're talking about the total time elapsed. So notice that the displacement is x final minus x initial, and the time is t final minus t initial. And that is therefore delta x over delta t. The average velocity of an object, of a moving object, of a bunny rabbit hopping across the room, is delta x over delta t, where delta x is the displacement of the object, not the distance. So you will notice that the average speed is a different measure than the average velocity. It's a different measure. Not only that, but the average speed is always a positive quantity, and the average velocity can be positive or negative depending on direction, depending on whether you're going along the positive x-axis, away from the origin, or towards the origin. Or in the negative, on the negative x-axis. Of course, we haven't even talked about that, right? Your x-axis has an origin, x equals 0, and this is plus x, and this is minus x. And so you could start here and move in that direction, and you're still moving in the plus x direction. Start here, move in that direction, you're still moving in the plus x direction. Start here, move in that direction, you're moving in the minus x direction. Start here and move in that direction, you're moving in the minus x direction. And so if you're moving toward the minus x direction, or along the minus x direction, then you're moving in the minus x direction. I'm not going to repeat that. That sounded repetitive. But really what it comes down to is if x final is bigger than or smaller than x initial, right? So if you're moving to the left along the axis that I drew, then you're moving the minus x axis, and moving the minus x direction. If you're moving to the right, you're moving the plus x direction. Okay, I think I've repeated that too many times. Okay, so units of average velocity, of course, units of average velocity are still meters per second. It's a measure of rate of change of distance or displacement. It's a distance over time, meters per second. Okay, let's do a quick example just to make sure that we understand the difference between average speed and average velocity. Let's say I walk from my office to the Skeller to the snack bar in 1 minute. So it's a straight, let's pretend it's a straight line and it's 60 meters away. Now, these numbers might be a little off, but whatever, that's fine. Let's say that this is my office and this is the Skeller. They're 60 meters away, right? So it's 60 meters away, and I'll walk there in 1 minute. I forgot to say how long it takes me to come back. Let's say that I realize I'm late for class, and so I run back. So this is along with up here. Run back in 10 seconds. I don't know if these numbers are reasonable, but close enough. run back in 10 seconds. So I walk to the scalar 60 meters away in 1 minute. I run back in 10 seconds. So I want to know when I am going to the scalar, what is my average speed and my average velocity? Well, so if I'm my average speed, remember, is my total path length traveled, which is 60 meters, over the total time elapsed, which is 1 minute. So when I'm going, oops, I didn't write average speed, equals average speed. Okay, so that's 60 meters per minute, right? So the average speed is 60 meters per minute. Or if you like, put it in seconds, right? There's 60 seconds per minute, so it's 1 meter per second. But what about my average velocity? Remember, the average speed we don't have a symbol for, we just call it average speed. Average velocity is V sub AVG, or AVE if you prefer for average, doesn't matter. Average velocity is my displacement over time, over total time. Displacement. For my displacement, I have to have an x-axis, right? I've got to have a coordinate axis. I've got to have a frame of reference. So I'm going to put a coordinate axis here. I'll just draw it right on top of what I already drew and call this the plus x direction. So that's the plus x direction. So now I can say, oh, okay, I start at x initial equals 0 meters and I finish at x final equals 60 meters when I'm going to the scalar. I never said this is my office and this is the scalar. I don't even know if that's how to spell scalar, but there might be an A in there somewhere. And so now I can say, oh, okay, x final minus x initial is indeed plus 60 meters. I put the plus because it could be negative if we went the other direction, right? I mean, if x final is less than x initial. So it could be positive or negative. So I explicitly put the plus, and you'll find that I do that for the quantities that have direction associated with them, that have signs associated with them. I'll try to explicitly put those signs. And the time is 1 minute or 60 seconds. And so the answer is plus 1 meter per second. Now, I actually want to say more about that plus sign. It is more important than you think it is. Because remember, average speed does not have a direction associated with it. The average speed is 1 meter per second, and it doesn't have a direction associated with it. The average velocity does have a direction associated with it. The average velocity is displacement over time, and displacement has a direction associated with it. Plus x, we're either moving in the plus x direction or the minus x direction. So the average velocity, since the displacement has a direction associated with it, the average velocity also has a direction associated with it. So the plus sign indicates direction. Now you might say, well, what if I leave off the plus sign? It's still a positive number. You are correct. It's still a positive number. But I do want you to explicitly recognize the direction of a quantity that has a direction associated with it. So it is 1 meter per second in the positive x direction, right? So the actual average velocity, V average, is equal to plus 1 meter per second, which what that means is 1 meters per second in the plus x direction. That's important to understand, that direction, because we're going to start using vector quantities that have direction, and you're going to have to pay attention to whether it's in the plus x direction, minus x direction, plus y direction, minus y direction, etc. Okay, so this is getting a little messy. Okay, maybe that's a bit better summarized. Now let's do coming back, right? Return, the return trip. The return trip. The average speed is, for the return trip, it's the total distance, which is 60 meters, over the total time. Now remember, the return trip was 10 seconds, turning. So the average speed is 6 meters per second. What's the average velocity? Now the average velocity, again, we could change our coordinate axis, but if we're going to compare the going to the returning, we got to use the same coordinate axis. So if my plus x direction is to the right, then when I'm returning, I'm moving in the negative direction, right? So when I'm returning, I'm going to start from, when I'm returning, I'm going to start from x initial equals 60 meters, and I'm going to finish at x final equals 0 meters. That's for the return trip. using the same coordinates, right? I mean, I could just start the problem over and just say, okay, I'm going to redefine my coordinate axis and redefine my origin. But I had already defined our frame of reference. Our frame of reference was a plus x-axis that started at my office. And so for the problem, we really want to stick with that frame of reference. So that means that the average velocity is the displacement, which is now x final, 0 meters, minus x initial, 60 meters, over the time elapsed, which is 10 seconds. And so my average velocity on the way back is minus 6 meters per second. And what that means is 6 meters per second in the minus x direction, right? The minus sign is it commutative, transitive, whatever. You can take it out in front of the x direction. So it's 6 meters per second in the minus x direction. Minus 6 meters per second, if I have defined my plus x as is, means 6 meters per second in the minus x direction. So notice that the average velocity is different than the average speed now. What about the round trip? What about the round trip? For the round trip, my average speed is total path length traveled. I went 60 meters out, 60 meters back. That is 120 meters. And for the round trip, it took me 60 seconds out, 10 seconds back. Total time elapsed is 70 seconds, right? There you go. And so therefore, for my round trip, my average speed is 1.7 meters per second for the round trip. My average velocity, on the other hand, average velocity, that just says average velocity, I'm not going to rewrite it, is my initial, so for the round trip, I initially started at x equals 0. And where do I end up? I end up at x equals 0. I'm ending up at the same place that I start at. So x final minus x initial, I'll just write this out. X final minus x initial, t final minus t initial. For the round trip, I've got, I finish at x equals 0. I start at x equals 0. The total time elapsed is still my final time minus my initial time. Initially, I started at t equals 0, let's say, and finally, I end at t equals 70 seconds. You got to be really careful about that, right? That this is still the total time elapsed. And so this is 70 seconds, but it doesn't matter because 0 minus 0 is 0. My average velocity is 0. And 0 doesn't really have units. If you put units, I'm not going to penalize you, but a 0 doesn't have units because